Now, what are the various factors of production means? As we have the five basic factors of production that are land, labor, capital, management, and technology. There are five factors which are five elements of production which will influences or which will changes the quantity of production. Guys, is it is audible? Hello?
Yes, ma'am.
Okay, ma'am. So now let us move to the new concept today, that is production function. Now, what is this production function? How we will define this one means, guys, like let us consider in the last unit as we have discussed about demand function. How we have defined the demand function means it represents the functional relationship between quantity demanded with demand determinants. This is demand function. In the same manner, now we will define the production function by using the same. That is, it is a functional relationship between quantity of production or else production quantity. Quantity produced or else production quantity with production determinants. See guys, here we said demand determinants. Now here we are saying production determinants. Okay, here it is quantity of demand. Now here it is production demand. There is a basic difference, and like as we have defined the demand function, like the same as here also we will define production function. Now, what is a production function? A production function is a technical relationship between inputs and outputs. That means, as we said, these are all nothing but the elements of production or else the determinants of production are the inputs. We are given the various inputs, we are employing the various inputs in order to get certain output, that is quantity of production. It explains the quantity of output produced by using the various input factors of production. So when we use the different types of input factors of production, then how these input factors will changes the quantity of production, that we have defined it as production function. See how we will define, that is guys, for understanding, if you want, we can write in other way, like see here Q, that is Q equal to functional relationship of, as we said in the demand, of production determinants. Now, a question arises, what are the production determinants, or else what are the factors of production? That is land, labor, capital, management, and technology. So what are production determinants means? As we discussed yesterday, production determinants, factors of production, are elements of production. All will be the same. Now, what are those? The first one, that is land, labor, capital, management, and technology. So when we will try to analyze the relationship between how these input factors are changing and ultimately the output is changing, such a relation is will call it as production function. See, land, labor, capital, management, and technology. Now the next one that we have, it is types of production function. Types of production function. Now as we said, like guys, what are the factors of production that we have written here? Land, labor, capital, management, and technology. Land, labor, capital, management, and technology. Now thus in all the situation, is it possible to us to change all the resources? For example, can you able to change the technology by tomorrow itself? Might not be possible. Basically, change in certain input factors might not be possible every time, or else here we have the concept of types of production function. How we can define or how we can classify the production functions means, it is based on the possibility of changing the production factor, the possibility of making certain changes in the factors of production. According to that, we have two types of production function: long run production function, short run production function. Depending upon the scope for the change in the input factors, the production function has been classified broadly into two types: short run production function, long run production function. Short run, as the name itself is saying that it is a short run, that means shorter period of time, that is less period of time. Now what are the various factors of production that we said here? Like land, labor, capital, or capital, management, and technology. These are the various factors of production. Short-term period means, like let us consider span of 3 months, 6 months, that will consider it as shorter period. Now, in a short-run time, can we able to change all the resources, all the factors of production? Means never be possible. For example, we want to change the technology that we are using. For that, first we need to develop the technology, need to provide the training to the employees. After that one, we need to test the technology, then it might be possible to implement the changes. For that, it will take a long period of time. As well as management. Can we change the management styles? The way that we organize the things, the way that the decision making styles. Can we change immediately? Means no. For making certain changes in the management style, we need to define our policies and procedures in a clear manner. And to define these policies and procedures, it is time consuming process. So management cannot be changed very easily. Next aspect that we have, it is capital. Yes, there is a scope for capital change, but it will also take more than a shorter period of time. So capital cannot be changed. The next one that we have, it is labor. Can we appoint more labor or can we appoint less labor in a short period of time? Yes, it is possible. Labor, appointment of labor can be possible easily. So in a short run period, what can be changed? Just for understanding, I am taking here. Okay, we will discuss this one in the next slide, previous one. For example, like let us consider the first factor of production, that is the labor. Can we able to change, land. Is it possible to change the land in a short run period? Means no. In the land, we said that the different types of natural resources. Natural resources in a shorter period cannot be changed. Change is not possible, not change. Okay, but whereas labor, is it possible to change the number of labor in a short run period? For example, by next week, we require some more faculty. Is it possible to appoint? Means yes. We can search for the competent people and it is possible to appoint. That means the labor can be changed in a short run period. Whereas capital, guys, availability of capital sources might be there, but it will take certain time duration for the verification process and all. If we will go to the bank, they will immediately issue the loan to us? Means no, it will take certain period of time for the verification and approval of that loan. That means in a short period of time, this is also not possible to change. Whereas management and technology, just now we said that management and technology cannot be changed. Now, what can be changed in a short run period? What can be changed in a short run period? Yes, 209. What can be changed in a short run period? Only one of the factors that we have, it is labor. So what is a short run production function? Means it is a production function but only one variable. Only one variable. Guys, another question arises. Why we have only one variable in a short run period? Even though they are constant, why we have not taken this one? Means, guys, see here, what is a production function? Means it is a relationship. It is a relationship between the quantity of production with respect to production variables. Production variables are factors of production. Now, we will take only those factors which can be changed. We will consider only those factors which can be where there is a possibility to change. So in a short period of time, there is only one factor that can be changed, that is labor. In short run, the producer can able to change all the production factors, and thus he can change the quantity of production only by changing the labor. In a short period of time, the producer can't be able to change all the factors of production. Because of that, what happened? It is possible for him to change only one factor, that is labor. Because of that, what happened? Yes, we have a short run production function with only one variable. And what is that single variable? Means it is labor. Okay, it is a functional relationship between quantity demanded with respect to labor. That is short run production function. The next type that we said, it is Long run production function. Guys, long run production function again classified into two types. A long run production function has been classified into two types. What are the two types of long run production functions? Means long run production function with the two variables, long run production function with all variables. See here, long run production function with all variables and long run production function with two variables. Why we'll have this one? Guys, understand short run period, long run period. For example, if it is less than a year, less than 1 year, short run period. For example, like greater than 1 and less than 3 years will be considered as medium term. Whereas the third one, if it is greater than 3 years, then long run time duration. Now, in a short run period, it is possible only to change only one factor, that is labor. But whereas in a medium term, it is possible to change two factors. One is one is labor, the other one is capital. Whereas in long period of time, that means when we have more time, then all the factors of production can be changed. So production function in long run has been classified into two types. That is, one we can call it as medium, other one is long run production function. Okay. In long run, the producer has the ability to change all the production factors. Now, the production function with two variables. Production function with two variables. What are those two variables? The long run production function with two variables can be represented as a Q equal to F of, that is functional relationship of L and C. What are L and C? L represents labor, C represents capital. That means in long run period of time, SI, if it is not short run but it is not too long, in that as it is possible for any producer to change two factors of production, that is land as well as capital. Because of that, as we have long run production function with two variables. Okay. The next one that we have, it is long run production function with all variables. For example, if we have 10 years of time, in such a case, can we able to change the technology? Yes, we can. Can we change the management? Yes, possible. Now the other factor that we have, that is the land, resources, land. So definitely if we will have more than 10 years, 15 years, that is a long run time duration. In that time, all the resources can be altered, can be changed. In such a case, what happened? We have the third type of production function, that is long run production function with all variables. Now, in long run, the producer has the ability to change all the variables of factors of production. Okay. Hence, in long run, the quantity of production depends upon all the factors of production. The quantity that we are going to produce will depends upon all the factors of production. Now, what are those factors of production? That is land, labor, capital, management and technology. So, in a long period of time, all what are the factors of production can be changed. That is land, labor, capital, management and technology. Okay. So, this is about what are the different types of production function. What is a production function and what are the different types of production function. What is a production function means? Yes, production function represents the functional relationship between factors of production with respect to quantity. Production variables with respect to quantity of production. Now, in a short period of time, just see here, all these are the various factors of production. What is a production function? It is a functional relationship between Q equal to F of production variables. Now, production variables. This is the basic formula for production, short run production function. Now, in a short run period, in short run, what happened? Can we able to change all the production factors? Means no. That is Q equal to F of only one factor. That means in a short period of time, only one factor can be changed, and that is labor. Because of that, what is the quantity of production variable? That is labor. Next one, long run production function. This long run production function, again we have two types. That is long run production function with two variables. Now, what are those two variables? That is Q equal to F of two variables. One is labor, the other one is C for capital. Two variables can be changed in a medium term, that is labor and capital. Whereas the another one that we have, it is the same long run production function with all variables. That means all the factors of production can be changed. All the factors of production can be changed. Because of that, as we have a production function, that is Q equal to F of all variables. What are the all variables that we have? Like land, labor, capital, management, technology, which we have already represented here. Just for understanding, I have written it in another slide. Okay. So this is about what is production function and what are the different types of production function. Okay. The next concept that we have, it is isoquants and isocast. Isoquants, isocast. Okay. Guys, before going to discuss the concept, first let us have an idea about why it is. Why we required isoquants, why we required isocast. For example, for production of isoquants and isocast will explains the relationship between two factors of production. The concept of isoquants and isocast explain relationship between two factors of production. What are those two means? Land and capital. Sorry, labor and capital. So what is the relationship between labor and capital? That can be understood by using the concepts of isoquants and isocast. Now, iso, as the name itself is saying that it is a combination of two words. One is iso, the other one is quants. Isoquants. Now, what it is? Basically, the term isoquants has been derived from a Greek word. Now, what is that Greek words? Now, two words that we have, that is one is iso, the second one is quants. What is the meaning of these two words in a Greek? Iso represents that same. Iso means same, similar. Okay. Quants is nothing but quantities. In Greek, the meaning of iso is same. Quants means quantities. Now, isoquants, that means same quantities. Same quantities. Guys, here sometimes what happen? For example, we want to, let us consider that you are doing a construction business. You want to have the same quantity of output. How can we get the same quantity of output? How we can able to produce the same quantity of output? For example, like let us consider we have more capital. In such a case, what happened? By using the less labor also we can produce. Capital intensive and labor intensive. We have the two systems, capital intensive, labor intensive. In the capital intensive, what happened? We have more fund with us so that we can invest more. From that, we can increase the productivity. That is capital intensive program. The second one that we have, it is labor intensive. Labor intensive means here we does not have the much more fund. Because of that, we depends upon the labor. Isoquants explains the relationship between how we can change. See here in the diagram, labor, capital. Guys, does the graph is clearly visible to you? I'll just zoom some more this one. See guys, here we have represented a curve here. Throughout the curve, IQ1, what is the number of units here represented? What are the number of units that I have taken here?
100.
100 units. It means that, see guys, here the capital is very high. It is not possible here because it is a diagram. Just for, I am putting the cursor, try to understand that one. For example, I'll take at the peak of this curve here. Capital is very high. See, capital is very high, but the labor is very less. But at this point, how much, what is the quantity of output that we are able to produce? 100 units. At any point throughout this curve, what is the output that we are getting means 100 units. Now, how we are getting throughout the curve, how we are able to get the same quantity of output means because of change in input factors. Change in input factors. For example, what happened? You and your friend are doing, your friends are doing, 5 people are doing a business. One person has more capital. In such a case, what happened? He will invest more money. They will invest They'll invest more on capital and less on labor. Invest more money on capital and less money on labor. By using that, what happened? He is producing 100 units. But whereas second person does not have more capital, in such a case, what happened? He can invest little bit less than compared to A, but he will little bit increases the number of labor. If A, for it, guys, I have a tabular representation also here. I'll show that one. See here. See, first person, what they did, A has used 10, A's capital is very high. A is financially very strong. Because of that, A has invested 25 units of capital and he has employed only 10 units of labor. A has invested 25 units of capital and only 10 members he has appointed as labor. What is the output that he is producing? Means 100 units. Whereas another person B, what happened? Not poor, not high. That means he does not he have moderate fund with him. That is not high capital, not low capital. He has invested 20 units of capital, but he also increased the number of labor compared to A. That is 15 units of labor. That is 20 and 15. But B also producing same 100 units of output. Whereas the last person, C does not have much more fund with him. Only minimum fund that is available. So C will employ only 18 units of capital but he will focus much more on labor. Because of that, what happened? All the three people, A will take here, B will take here, C will take here. A, B, C, all the people are producing same unit. Such a curve, see here, the curve which represents two input factors, the curve representing the two input factors and for getting same quantity, then we will call such curve as isoquant. Just this is the basic explanation for isoquant. Now let us see the basic definition for this isoquants. How we can define this isoquants? Thus, isoquant is a curve with different combination of two input factors. Guys, as we have seen just now, A what he did? 20 units of capital, 10 units of labor. B 15 units, 25 units. C 18 units, 30 units. That is representing a curve. It is a curve. See here. This is a curve representing here at any point if we will take. It is a x-axis data, y-axis data. That means two input factors that we have. So it is a combination of two input factors that produces same quantity of output. What is an isoquant means? Isoquant is a curve that represents two combination of two input factors producing same quantity of output. It can also be known as isoproduct. We can also call the isoquant as isoproduct. Isoquants or isoproduct, both will be same. See here. Now this is an isoquant. A, B, C, first we will represent, after that one we will join a line. Then such a line is known as isoquants. Why we will call this as an isoquant means because at any point if we will take, then at every point we have each point is representing combination of two input factors and each combination is producing the same quantity of output. Okay, this is one of the example that we have taken. See here. Same quantity 100 units can be produced for different combination of inputs 10, 25, 15, 20, 20, 18. By using this one, what happened? But still the person is able to produce the same quantity of output. Such a curve we will call isoquants. Guys, important. Isoquants, isocast. Okay. Next one. Let us move to the next. That is, what are the properties of isoquants? What are the basic properties of isoquants means? As isoquants are down sloping curves, convex to origin, never touches the axis, no two isoquants intersect with each other, higher isoquants move against the origin. I'll explain each point. The first point here we have represent, that is downward sloping curve. Downward sloping curve. See guys, the shape of an isoquant. What is the property of this downward sloping curve? Explaining means it represents that when we will represent the diagram, two input factors on a diagram, then it will be in a shape of, a downward sloping curve. This type of curve, that we'll call it as downward sloping curve, whose slope is always negative. The slope of this curve is always negative. See here, the first property, downward slope. The slope downward, they slope downward. Why? Because MRTS of labor for capital diminishes. Basically, why it will be a downward sloping means marginal rate of technical substitution. We have a separate concept on this one that we will discuss. What it is means substitution. For example, guys, by using the less labor, we want to get the same quantity. We have less labor available, but still we don't want to compromise on the quantity. In such a case, what happens? Capital has to be invested more. That means either more incentives has to be provided to the employees, or else more technology has to be implemented. By using that one, what happens? Ultimately, we will get the same quantity outward. So, as the labor increases, capital decreases, or else reverse also possible. When the capital decreases, labor will increases. When an increase in labor we have to decrease the capital to produce a given level of output. When we have more number of labor available, in such a case, if we invest more capital on the machines, on the different types of equipment, in such a case, what happens? Capital will move on. Because of that, in order to minimize that, as we will decrease the capital. Because of that, what happens? The slope of a curve, isoquant curve, will be always downward sloping curve. That is the first property of isoquant. What is the second property? Convex. Guys, it is already clear why it is convex to the origin. See, you have the knowledge about convex and concave to the concave. Convex and concave. So the shape of this curve, see, from the origin, if we will observe, what is its shape means it is concave, convex, sorry. So here, convex to the origin. The slope of the shape of the curve will be always convex from origin. The downward sloping curve may be convex curve, concave, or even a straight line. In some cases, yes, it will differ. But in case of isoquants, generally, if we will see the downward sloping curve, it may be convex, concave, or even straight also. Due to MRTS, the shape of an isoquant will be convex to origin. As we said, if when one increasing, the other one decreases. Because of that, what happens? Always the shape of a isoquant will be convex. Okay. Next one. Never touches the axis. Never touches the axis. Guys, first let us see the diagram related to that. After that, we will discuss. Touches the axis. For example, one of the property we said just now that it is never touches axis. Let us consider it touches the axis. For example, this is an isoquant. This is also an isoquant. If an isoquant touching this capital, that is y-axis, then what does it mean? It means that zero capital. Zero, that means, isoquant line is touching the capital line means the capital will become zero. The capital is, labor is zero. This isoquant line is touching the capital line means labor is zero, but still capital is very high. That means without the involvement of any person, can we at least able to generate the capital means no. As we said yesterday's class, labor, even the investor, CEO of a company is also a labor. CEO of a company or else the investor of a company is also a labor. In such a case, if there is zero labor, how can we get the capital required for a business? It is meaningless. It is meaningless. That means we agree that the isoquant never touches y-axis. Isoquant should not touch y-axis. Why it should not touch y-axis? Because it never be possible that the labor of any business will become 0. That is one point clear, that it never touches y-axis. Now let us move to the next one, that is x-axis. Okay, it never touches the y-axis. Does it touches the x-axis? Does it touches the x-axis? Now for this also we can say, see here we have large number of labor. Thousands of labor are available, but there is no capital. I mean, at least leave about the machines. At least in order to purchase certain type of materials, we require the labor. We require the capital. Labor will process the materials, but in order to start the process, first we require certain capital should be available. So when the labor might be high, but when the capital is 0, then there is no existence of any business. Because of that, we can conclude that an isoquant curve is one that never touches neither the x-axis nor y-axis. It never touches x-axis, it never touches y-axis. The production won't be possible without labor alone. If we have the labor alone, does we have any production? Means no, never be possible. Or capital alone. Even though we have the capital alone, means generation of the capital alone never be possible without any labor. Thus, an isoquant never touches either the axis, not the x nor the y axis. This is the explanation for that one. The next property that we said, that is no two isoquants intersect each other. Point of intersection means cutting each other. Intersection is nothing but cut each other. Guys, I analyze this one. See, I am just increasing the size of this diagram for the understanding purpose. See guys, we have two different isoquants. One is producing 100 units, the other one is producing 50 units. Now, if they will intersect, here we have a point of intersection. Here we have a point of intersection. Let us name that point as A. Now, A is at A, we have certain number of labor as well as certain number of capital. Now, what is concluded from here? By using the combination of A, that means, for example, come to this, I am minimizing this one, just a minute. For example, A combination that I will take like 15 units of labor and 5 units of capital. What is the meaning of this diagram? What is the meaning of this diagram? Means this point A, that is 15 labor and 5 units of capital, can be used to produce 50 units, 100 units, as well as the same combination can be used to produce 50 units. Is it possible? We are not going to change the combination of inputs. Both are for a case A and case B. Same 15 labor and 5 units of capital. One case they are producing 100, other case they are producing 50. It never be possible. Because we are discussing in an economical point of view. Economical point of view means always it will say optimum utilization of resources. In such a case, by using the same combination of input factors, it never be possible to generate two different quantities of output. Because of that, no two isoquants will intersect each other. No two isoquants intersect each other. A producer can't be able to produce two different quantities of output by using same combination of two input factors. Just now I said A 15, 5 producing 50 units, producing 100 units. It is never possible. Okay. So hence two isoquants won't touches each other, won't intersect each other. Always it will maintain certain gap. And the last property of an isoquant, that is higher isoquants moves against the origin. For example, again for this we need to increase the size of this diagram. See guys, in this figure it is clearly specified when the quantity of production increasing. See, for the third one, IQ3, what is the quantity? 50 units. When it has been increased to 100, now this curve from here, it has been shifted to here. That means it is moving, keep on against to the origin. 100 units. If we have 300 units, Does the curve will falls here or else in this area? Means definitely the curve will comes in this area. Why? Because always whenever the quantity of production increases, it will move against to the origin. Higher isoquants moves against to the origin. So these are the various properties of isoquants. Guys, what is isoquant? What are the properties of isoquants? Isoquant is a combination of two input factors producing same quantities. What are the properties of isoquants? First one, it is a downward shape, sloping curve. I mean, by the shape itself we can identify. Next one, that is the downward sloping curve. It never intersect with the convex to the origin. That means the shape of the curve, it is always, if we will observe, if we will stand at the origin point, then what is the shape of that isoquant? Means it is convex in shape. Next one, never touches the axis. That means an isoquant never touches either x-axis nor y-axis at the same time. Even the two isoquants never intersect with each other. And the last one that we have, as the isoquant quantity is increasing, it will move against to the origin. 1000 units, it will somewhere falls here. So these are the properties of isoquants. What are isoquants and what are the basic properties of isoquants? The next one that we have, it is isocast. Isocast. Here also the same. It is also derived from a Greek word iso and cast. Isocast. Now, isocast, which means same cast. Same cost of production. Same cost of production. See, isocast represents a line with two input factors. Guys, if you remember, at isoquants, we said it is a curve. Isoquant is a, sorry, I'm moving to downside. Isoquant is a, see, isoquant, we said that it is a curve, but whereas isocast, we are saying, see, isoquant, it is a curve, but whereas an isocast will always be represented as a line, a straight line. Okay. Now, what is an isocast? Means it is a line with again two input factors. Guys, as I said, isoquants and isocast will explain the behavior of long run production function with the two variables. Isocast, isoquants explains the behavior of production function with two variables. Okay, a line with two input factors of production with cost same, where the cost of the project will be the same. Cost of the project is same. Cost same to the producer. With respect to the producer point of view, the cost of production will be same. Thus, as we are saying, we are talking about the cost budgeting system. Because of that, this is also known as a budget line. The isoquants can be known as iso product, whereas isocast can be known as a budget line. Isocast will be known as budget line. Okay. Now, suppose that a producer have he is having a total budget of 1000 rupees, and for the producing a certain level of output, he has only, what is the amount that is available with the producer? Means he has only 1000 rupees with him. Now he need to achieve a level of output, and he has to spend his amount on two factors of production. That means by using that available 1000 rupees on the two different factors of production, he need to achieve a certain level of output. Price of labor and capital are 15 and 10 respectively. That means what are the labor charges? Means 15 rupees is the labor charge, and what is the capital cost? Cost of capital is 10 rupees respectively. In such a case, how we can do this one? See. Yes, ma'am. Does the table visible to you clearly? Does the figures? Is it clear? Or else shall I bold that one? Yes. See here, we have different input factors. We will increase the size. See, labor is 40 labor that he has employed and 40 units of capital. What is the total cost of the project is 1000. As we already said, labor is 15 into 40, capital 15 into 40, it is 600. Why 15 into 40? Because here already we said that what is the cost of labor? 15 rupees is the cost of labor, 10 rupees is the cost of capital. In such a case, how many labor we are employing? 40. Each labor cost is 15. 15 into 40, that is 600. Plus, what is the cost of capital? It is 10 rupees. 10 into 40, that is 400. 600 plus 400, that will become 1000 here. Cost of the project is 1000. In the other case, in the second case, B, what he did? He has less labor. Less labor are available. In such a case, he has increased the capital. He has increased the capital by 55 and decreased the labor to 30. But still here also, 30 into 15, 45, 450. Here it is the 550. 55 into 10. That will become again 1000. Like this one. See here, it is a ABC. When we will represent, when we will draw a line showing ABC on a curve, then we will call such a line as isocast. See this one. ABC that we have represented on a line, and when we have joined this, this has been plotted as a straight line, and on that line, what is the cost of entire line means the same 1000. That means if we will decrease the labor, then we will increase the capital, or else when we will increase the capital, we will decrease the labor. But still the cost, how we will do the changes means in such a way that the cost of the project might be same. The cost of the project will remain same. Such a combination of two input factors, as we will call it as isocast. Okay. Now, what are the properties of isocast? Again, like isoquants, the higher isocast will move against to the origin. For example, guys, see here. This is IC1, that is the 1000 units produced. IC1, that is the isocast curve 1000. For example, if we will represent in the same diagram, that is IC1 for 10,000 cast. Then does it will come here in this region, or else in this region means definitely it will come in the higher region. Okay, that is the first property. As the higher isoquants will move against to the origin. Yes, the second property that we have is always a straight line. Guys, isoquants in depending upon the substrate MRTS, isoquant may become a curve or even a line also. But isocast will be always a straight line only. Whatever might be the MRTS and whatever might be the quantity of production, always this isocast will move in a straight line direction only. So these are the properties of isoquants. Now, what is the use of this isoquants and isocast means? Least cost combination. We will use the concepts of isoquants and isocast in order to find out a least cost combination. Least cost combination. Now, what is a least cost combination of outputs? Guys, what is the basic objective of any organization? Maximization of profit. Any business, they want to maximize their profit. We will take a rough figure here. For example, like let us consider every business want to maximize their profit. How we will calculate the profit? Profit equal to selling price minus cost of production. We cannot increase the selling price, because if we will increase the selling price, what happens? The competition may affect. But whereas the other one that we have, that we can reduce the cost of production. We can reduce the cost of production. So here what happened? How we can reduce the cost of production? Mamata, mute or else I'll remove you from the class. How we can reduce the cost of production? That is by using a least cost combination. How we can able to reduce the cost of a project? In order to reduce the cost of a project, we will use the concept of least cost combination. Now, under this least cost combination, what happened? How we'll find out the least cost combination? Simple thing, guys. See here we have. This is isocast curve. This is an isoquant curve. Isoquant, isocast. Another thing that to understand this least cost combination that we should know, that is, guys, for example, like let us consider you want to minimize your expenses. Your father said that have a control on your pocket money. Now, uh, in order to control your pocket money, every month or else for a week you require 2 pence. And to purchase 2 pence, you need to spend 20 rupees, let us suppose. 20 rupees will be spent in order to purchase 2 pence. Now, to minimize your expenses, can you purchase a single pen? That is a right decision by spending 10 rupees, and you can tell to your father that I have saved 10 rupees this week. This is a right decision? Cost has been spent, reduced. The expenses which has been incurred has been reduced. But does this kind of reduction, does it is right? Every week you used to spend 20 rupees and you required minimum of 2 pence. Because of that you are spending 20 rupees. Now, in order to save money, what you did, you have purchased only 1 pen and you have spent 10 rupees on the pen. If that is your saving, shall we consider that as your saving? Grishma? Yes, guys, does it is a saving? Can anyone? Never. Why? Because here our minimum requirement is 2 pence. Then in such a case, if I have only 1 pen, what happens? Such a saving is waste of use. It is waste. As the second case that we can say, that is, now let us consider here what is the second case that we will take here means, we will compromise with first one quantity, we will increase the cost of production. Can we increase means no, it has to be reduced. Now for that, in order to find out the right combination, how much money has to be spent and how it has to be spent, as we will use combine the concepts of iso-cost, iso-funds. By superimposing this iso-cost curve on iso-funds, we can able to identify or determine a least cost combination of output. We can find out a least cost combination of output by superimposing iso-cost on iso-funds. Now let us see, this is the basic explanation for least cost combination. The basic objective of a producer is to maximize the profit, as we just said. Maximization of profits of a firm by producing more unit, more output, by employing less input factor. How we can maximize our profit means by using the less input, but still we need to extract more output. The combination of two input factors which gives the maximum output. See, here also as we will take two input factors, a combination of two input factors that gives maximum output. That means the output which we require cannot be compromised, cannot be reduced by using minimum input factors is known as least cost combination. We want to get same 2 pence, but we will reduce. How we can do that one means that can be found by using the concept of least cost combination. Now, what are the assumptions of this least cost combination? There are two factors of production. There are only two factors of production and all the other production factors are kept constant. That is the first assumption. Next one, the input factors of production are homogeneous. Homogeneous, heterogeneous. Basically, guys, homogeneous means with the same, what the labor 1 able to do, labor 2 will also able to do the same thing. What X produces the same quantity, that Y will also produces the same. In such a case, we will call it as a homogeneous inputs. Okay. The next one that we have, it is prices of input factors has been kept constant. If the prices of input factors changes, then what happens? The cost of production will changes. ISO cost will changes. So we are not going to entertain any kind of changes in the prices of factors of production. The next one that we have, it is the basic objective of firm is to maximize the profit. When the objective of a firm is maximization of profit, then only we will calculate or determine this least cost combination. Okay, so this is what is a least cost combination. What is least cost combination? Now, how we can find out that? A least cost combination is one. It is a fact. I mean, two input factors that will produce the same amount of quantity, same quantity without increasing expenses. Okay. Now, how we can do that one? Determination of least cost combination. How we can determine such a combination of two input factors? A firm can find out a least cost combination by superimposing the ISO funds on ISO curves. Just now, as we said, as we have the two different curves here, this is ISO curves, this is ISO funds. What we will do means we will superimpose. That means on the same graph as we will represent both the ISO funds as well as ISO curves. Then we will find out a combination of input factors. Let us suppose that a firm has a project costing 1000 and the ISO quant and ISO cost are represented as below. The cost of that means the budget of that ISO quant is 1000 rupees and we have an ISO quant accordingly. Now see here, these are the ISO quant curves and these are ISO cost curves. When we will superimpose the ISO cost curves on ISO quant, see this is one. Previously, it's the same diagram that we have taken. Here we have taken different ISO cost. Here we have taken the different ISO quants. Now, by using this one, we will able to find out the point where the ISO quant and ISO cost touches each other, or else where what is the least cost combination of output means the point where the ISO cost line will become a tangent to ISO quant. ISO cost line will become tangent to ISO cost line. See here, in the first curve, when this IQ1 equal to 1000 units, what happened? This is ISO cost is somewhere else, but the quantity is very less here. So this is not a right combination of output because we have more available fund with us. Next one, it is becoming a tangent, but it is a perfect aspect for cost. Now the third one, see here, when the ISO quant is 3000, basically our project, our cost line here at 2000 itself, but this ISO quant, see the gap between the ISO quant and this curve, the gap between the second curve, that is 2000 ISO cost and this curve, this B that I have written there, that gap represents that the cost is only 10,000, but in order to produce this quantity, we have to increase our cost of production, which is not possible. Because of that, as we will find out, we will determine what is the least cost combination means. It is a point where the ISO cost will become a tangent, or else ISO cost will will become a tangent to ISO quant. Such a line as we will call it as such a point we will call it as least cost combination. To determine the least cost combination, let us superimpose the ISO quants on ISO cost. In the figure, ISO quant IC1 become a tangent to IQ2. See here, IC1 is becoming a tangent to C2. IC1.
Ma'am,
yes, ma'am.
if we get more than 1 point,
if we will get more than if we will get more than 1 point, then we can take any, and it will never happen. That is what we said.
Okay, ma'am.
That is what under the properties of ISO quant that we said. By using the same point, same combination, it is never be possible to get different outputs. So such an issue will never arise here. Okay. So
okay, ma'am.
If it is below, see guys, here below also we have, but below why we are not taking? We have more budget. Basically, the budget available to us is 10,000, but we are producing only 500 units. We can able to produce 1000 units with the available budget. Here it has become a tangent, but in the third one, our budget is less, but the quantity that we want to target, we have targeted is very high. That is also not possible. So IQ1 will become a tangent to IC1 will become a tangent to IQ2. At that point, it is B. Thus, the point B is considered as a least cost combination. Thus, the firm can employ OC capital and OL labor. See, we have represented. These are the number of capital, units of capital has to be employed, and these represent the number of labor that has to be employed. So that labor to produce 2000 units. How we have decided it is 2000? See in the figure. At this tangent, what is the ISO fund that we have? 2000 units. If we will use this one and produces 1000 units, it is meaningless. That is never be a, what is that, least cost combination. Okay, we have to produce 2000 units, then only that will become a least cost combination. This is what is ISO funds, what are ISO funds, what are ISO cost, what is least cost combination. Today we have discussed about production function, types of production function. That is short run production function, long run production function with two variables, long run production function with all variables. The next concepts we have discussed, what are ISO funds, what are ISO cost. From this ISO funds and ISO cost, what is the least cost combination? How we can identify a combination that will produce us at a minimum combination. Okay. Now, the next concept that we have, it is law of returns. Basically, guys, in the syllabus it has been specified as law of returns. Law of returns are of two types: returns to scale, return to factors. That is the next one that we will see. But to understand the law of returns to scale or returns to factors, we should have the idea about certain aspects. Three basic elements: total product, marginal product, average product. Total RLs, guys, we can also call this as total product or total productivity. Same. TP, AP, MP. Total product, marginal product, average product. Okay. Now let us, why we require this one means I will show you. See the diagram which I have represented here. We will divide the different stages in the law of returns. Stage 1, stage 2, stage 3. How we will define? See in this diagram you are able to see the three different types here. AP, MP, TP. AP, MP, TP. That is total product, average product, marginal product. So for that, let us have a brief idea about what are these, how to calculate. After that, we will discuss about the laws. Okay. The first one that here we have, it is total product. Total product. What is a total product means? The total product of variable factors is a maximum output. The maximum output produced by combining a given input with two fixed factors of production. When we use certain fixed factors of production, then what is the total quantity that we have produced? What is the total quantity that has been produced by using the fixed factors of production? For example, when we have used 10 units of labor, what is a 10 units of labor means? One labor will produce 10 units. See, I have a diagram also here. I mean, this is a chart. See here, when we will use only one labor will producing 100 units, two labors will produce us, one is producing 100 units, the other one is producing 200 units. What is the total product means? When we will combine all. For your understanding, I am writing here, we'll take three labor, one labor is producing 20 units, second labor is producing the 35 units, third labor is producing 29 units. Then what is total product? What is total product means? 20 plus 35 plus 29. That means like 65, 75, 85, 84. Here the total product will become 84. Not only a single input factor, for understanding I have taken one. Whatever the input factors that we have employed, combination including all, what is the total output that we have produced? That we will call it as total output. It is a summation of QIP that I have written here. That is quantity of input factors employed. The quantity of total input factors that has been employed, that we will call it as TP, total product. With this I will conclude just guys, two basic definitions. Average product. What is the average means? For example, three people has been employed here. Three are producing 84 units. Three are producing 84 units. In such a case, what is the average? Average product, that is AP. Now, what is the average product means? 84, 94. What is the average product here? Total product by total labor employed. Now, what is the average? That is 94 divided by how many labor employed? 3. That will become the average. That means on an average, what is the productivity of a labor? That is average product. Then last one that we have, it is marginal product. Guys, very important concept, that is marginal. I mean, total and average, as it is very familiar to us, as we will heard many more about this one. But marginal product, what is marginal product or marginal productivity means? Change in total product with respect to change in total quantity of input factors. For example, instead of 3 people are producing the 4 for 94 units of labor. For example, when we'll employ fourth labor, then what is the change in output? For example, fourth labor is producing 44 units. Then what is the total product will become now? That is 138. 8 is not working in my keyboard, because of this I am taking some other key. 37. This is the total product. Now, how we'll calculate this marginal product means difference in total product. Now it is 137. Previously, how much it is? 94. That is 137 minus 94 divided by TQ. What is TQ? Change in quantity of input factors employed. That is previous. Now it is 4. Previously it is only 3. That is 4 minus 1. That will become again 43. So that will call it as marginal product. Okay. Total product, average product, marginal product. Based upon these 3 values, as we will classify the different stages and law of returns. The different stages in law of returns can be classified based upon the total product, average product, and marginal product values. That will continue it in the next class. Guys, any doubts? In the concepts which I have discussed today, and already at the beginning of the class, it has been noticed that the questions are missing in the assignment which I have given yesterday. I'll make that change today and forward it to you by today evening. Okay. Any doubts? Any repetitions? Guys, are you able to get the material from that? I have attached a file also. Yes, can anyone? Yes, ma. Bhuvana? Grishma? Anyone? Hello? Yes.
No, ma'am, it's not opening.
Basically, guys, I have made 2 attachments. One assignment. The other one is the material. Okay, I'll check. What is the technical problem in that one? I'll re-upload it once again. Okay, there are 2 uploads for this. Okay, guys. Any doubts? If nothing else, then give me your attendance. Today is 16th. I'll call the numbers 61, 62, 63.
Present, ma'am.
Okay, ma. 64.
Present, ma'am.
Okay. 65. Roll number 65. Okay, ma. 66. Present.
Present, ma'am.
67. 68.
Present, ma'am.
68 present. Yes, present. 69.
Present, ma'am.
70.
Present, ma'am.
71.
Present, ma'am.
72.
Present, ma'am.
73.
Present, ma'am.
74.
Present, ma'am.
75.
Present, ma'am.
76.
Present, ma'am.
77. 78.
78 present, ma'am.
Okay, ma. 79.
Present, ma'am. 79.
80.
Present, ma'am.
81. 81. 82.
Present, ma'am. 82.
88, ma. 83.
Present, ma'am.
84.
Present, ma'am.
Sunil. 85.
Present, ma'am.
Manidhi. 86.
Present, ma'am.
Rahul. 87. 88.
Yes, ma'am.
Okay, ma. 89.
Present, ma'am.
90.
Present, madam.
Bhuvana. 91. 92. 93.
Present, ma'am.
93 present. 94.
Present, ma'am.
95. 96.
Present, ma'am.
Okay, ma'am. 96. 97.
Present, ma'am.
98. 99.
Present, ma'am.
99.
Present, ma'am.
99 present. Okay. A naught.
Present, ma'am.
A1.
Present, ma'am.
A2. A3. A4.
Present, ma'am.
Okay, ma'am. A4. A5.
Present, ma'am.
A6.
Present, ma'am.
A7.
Present, ma'am.
A8.
Present, ma'am.
A9.
Present, ma'am.
B0.
Present, ma'am.
B1.
Present, ma'am.
B2.
Present, ma'am.
B2. Okay, ma'am. Divya.
B2.
B3. B4. B5.
Present, ma'am.
B5 Charan. Okay, ma'am. B6.
Present, ma'am. B6 present.
B7. B8.
B8 present, ma'am.
B9. C0. Elisma. 7. 8. Okay, 8.
Present, ma'am.
9.
Present, ma'am.
LE9. LE10.
Present, ma'am.
11. LE11. Okay. 12. 11 I have marked. 12. LE12. Next, C section. C1. C2.
Present, ma'am.
C3. C4. C5. C4 present. C5. C6.
Present, ma'am.
C7.
Present, ma'am.
Okay, ma. C8. C9.
Present, ma'am.
C9. Okay, mark. C9. D1. D0. D1.
Present, ma'am.
Yes, ma'am. D2.
Present, ma'am.
D3.
Present, ma'am.
D3. Okay. D4.
Present, ma'am.
D5.
Present, ma'am.
D5. Okay.
Present, ma'am.
Okay, ma'am. D6. D7. D8.
D7 present, ma'am.
Yes, ma'am. D8. D9. E0. E1.
Present, ma'am. E1 present, ma'am.
Yes, ma'am. E2.
Present, ma'am.
Okay, okay. E3.
Present, ma'am.
E4.
Present, ma'am.
E5. E6. E7. E7. E8.
Present, ma'am.
E9. F0. Yes, F0 present. F1.
Present, ma'am.
Yes,
Present,
ma'am.
ma'am.
F1. Okay.
Present, ma'am.
Nandini. Oh, F2. F3 present.
Present, ma'am.
F4. F5.
Yes, ma'am.
F5. F6.
Yes, ma'am.
Yes, yes, yes. F6
present, ma'am.
present. F7. F8. F9. G0. G1.
G not present, ma'am. G
G
not
not
present.
present. G1. G2. G3. G4
Present, ma'am.
present. G5. G6. G7. G8,
Present, ma'am.
G7 present. G8.
Present, ma'am.
G9. H0.
Present, ma'am.
Present. H1. H2.
Present, ma'am.
H3.
Present, ma'am.
H4.
Present, ma'am.
H5.
Present, ma'am.
H6. H7. H8.
Present, ma'am.
H8 present. H9.
Present, ma'am.
J0. Elisma. 13.
Present, ma'am.
14.
Present, ma'am.
15. LE 15.
Present, ma'am.
LE 16.
15 present, ma'am.
Yeah. 16.
16. Present, ma'am.
17, 18. Okay, guys, thank you.
Ma'am.
Yes, ma'am.
A1 present, ma'am.
Number
One
A1
to A1.
present. Guys, give the attendance at the time only. If you will tell, then it is waste of time. A1 present, I have already marked your attendance.
Okay. Thank you.
Okay? Okay, ma'am. Thank you.